Okay, hello class. Welcome to the second lecture of computer programming for engineers course. So we are on the second week. This week and next week, we will learn about C++ basic. So no difficult concept in this week's. So take easy and enjoy the class. And there are something to correct about this course. In the last lecture, I announced that there's no class on week 4, but I just realized that I cannot just keep the classes due to the university policies. So I'm so sorry, but due to the university policies, I can't just keep the lectures on this week. So on week 4 Monday, the 20th of September, I will upload video clips on iCampus and programming exercise on Google platform. So please watch the video by 26th of September. And the deadline for programming exercise is October 1st. So just for this week, I'm giving you the 2 weeks for the programming exercise so that you have time to ask questions about program exercise on week 5 Wednesdays during the lab sessions. So I'm so sorry again for these changes, but due to the university policies, I have no choice, so please understand this. So because there is program exercise on week 4, the weekly assignments, the program exercise, the total number of program exercise is 12, not 11. And you don't need to submit the solutions of program exercise on iCampus, so just ignore this sentence. And all the demo code used in the lecture will be uploaded to this URL. So this URL has been changes, so don't go to this URL. The repository in this URL has been deleted. Visit to this URL. So as we learned last week, C++ is a superset of C. So whatever you do in C, you can also do in C++. But there are some differences between C and C++ because C++ extend C to make better programming languages. So in this lecture, we will mainly focus on these differences and extended aspect of C++. And throughout the course, we will learn about the concept of object-oriented programming, which is very important in these days. And I will explicitly mark C++ 11 or C++ 17 if we are talking about the language features introduced in these versions. Otherwise, if I do not mention anything about the programming versions, typically they are from C++ 98. So this is the goal of today's lectures. We will talk about the variables, types, variable declarations and type deductions, constants, enumerations, program style, namespace, and console I/O briefly. So let's study variables and types first. So what is the variables? Variable is a memory locations or storage area that the program stores data. And the name of the variable is called identifier. You can use this identifier to access memory location mapped to the variables. And you must declare the variables before accessing it. So you cannot use the undeclared variables. I will show a very quick example code. So you look at this code, there is a two variable, x and y. They both are typed int. So cout is a kind of printf in C. So using this, you can printing something out to your console or window in your computer. So x is 10 and y is x plus 1. So 10 plus 1 is 11. So y should be 11. So if I compile this program and run it, it prints 11 because I'm printing y. So undeclared variable means, so if I delete this line, there is no x. X is not declared in these programs. But if you try to save this, the compiler gives error because of the use of undeclared identifier x here. So we are using x, which is not declared in the program. So this is undeclared variable. So we cannot do something like this. So you must always declare the variable before using it. Okay, so go back to the slide. And there are two types of identifiers. The first, the name of the variable is identifier. And also the keywords are another class of identifiers. So keywords have predefined meanings and they cannot be redefined by programmers. So the example of keywords are shown here. The if, new, char, int, do, while, they are all keywords, and you cannot use these keywords as variable names, or you cannot redefine these keywords. So in the identifiers are case sensitive. So here there are 3 rate, all small letters, just 1 capital letters, and all capital letters. They are all different and distinct identifier because variable names are case sensitive. And the identifier must start with either a letter or the underscore symbol. So these are all valid identifier because it starts with letter and underscore symbol. But these are not legal identifier because they do not start with letter or underscore symbol. So that is the rule. And always make a meaningful name for the variables. This is a good programming practice. This makes the program much more easy to understand and maintainable. So for example, let's assume that there are two variable x and student age, and they both stores the integer value 11. But the for the student age, we can understand and we can infer that this variable stores the age of students. So we know what 11 means is the age of the students. But for the variable x, we do not know what 11 means because the name does not gives any information to us. So always use meaningful name for the variable names. That will make your program much more better. And since the variable is the memory location that the program stores data, we have to specify what types of data can be stored in that memory location. So we also have to declare the types when we are declaring the variable. So same as C, there are short, int, and float and double types. Short, int, long, types of variable can store the whole numbers, and the size of them are different. One short is 2 bytes, int and long is 4 bytes, float is also 4 bytes, but it can have a digit, and double is 8 bytes, and it can have 15 digits. So the size range for int is this one is big number. But what happens if we store more larger data than this size to the int variable? So let's see the code example for that one. So let's look at this one. So so in this program, we defined variable called test, variable name test, and it's int type, and it stores the maximum number that int variable can store. And if we print this one, this program should print this number. So let's compile this and run it. Yeah, it prints the, as expected, it prints this number. But what happens if we store more larger data to this variable? As you can see, it's this data is greater than this one. So what happens if we store this large data to this int variable? So if we compile this, compiler gives warnings, but it compiles well. If I run it, it doesn't give us the correct number here. It's because this data size is greater than the int variable type, it overflows the memory locations of this variable. So it returns the unexpected return value, the negative value, because data is overflowed. So this is what happens if you store larger data than expected into the specific variables. So be careful about this. And there are long double type. Usually double uses 8 bytes of memory, and long double uses more memory, to 10 bytes. But for VC++ compiler, double and long double both uses 8 bytes of memory, so they are same. So the size of each type is very much depends on your compilers and the machines. And bool type stores 2 values, true and false. This type only exists in C++. There is no bool type in C. And char type is for a single ASCII character, and its size is 1 byte. In C++11, new integral types are introduced because the size of integer data types are different between one machine to another. So for example, on a 32-bit machines, the int type might be 4 bytes, but on 64-bit machines, an int type might be 8 bytes. So depending on the machines and the CPU, the size of the types can be different. So starting from C++11, these new integral types shown in these slides are introduced, and their size are fixed regardless of the machines. So one example, the size of uint32 _ t is 4 bytes in both 32 bits and 64-bit machines. So the size is fixed. And size T is a special type defined in C and C++ standard. It is very convenient to store the size of value. So typically, it represents the size of types or variables in terms of bytes. So we use size of operator for calculating the size of types or variable like this one. So if you want to calculate the size of types, you pass the types here. And if you want to get a size of the variable, all you need to do is pass the variable name here. So if you do that, this operator will return the size of given input. So let's see the demo code for the size of operator. Size of the C. Okay, so here the size, there is 4 size T variable types of variables: int size, unsigned int size, short size, and unsigned short size. And you can get the size of this type by using size of operator like this. So size T type is very convenient in these use cases. You don't need to worry about the size of return value of size of operators. All you need to do is just declare the size of T type and receive the value of the return value of the size of. So don't worry, you don't need to worry about the return value. This is very convenient. And here we print out these variables. So if we compile this and run it, so as you can see here, int size is 4, unsigned int size is 4, short is 2, and unsigned short is 2. So this is very useful types. Okay, let's go to the so this is the code we just have executed. And in C++, there is a string class. String class is different to the data type we have seen so far, such as int, double, and float. So we will discuss more about the differences between class and data type in week 4. For now, just understand that string is a class, not primitive data type, and it is used to store string value. And in C++ 11, row string literals feature is newly introduced. This is very useful once you know it. So I believe that you have already learned escape sequence in C. The escape sequence start with backslash, and depending on the preceding character, compiler interpret it differently. So backslash T is a escape sequence and its meaning is a tap. And similarly, backslash N is also escape sequence and it indicates a new line. Double backslash T means /T. So this is not a escape sequence. So I will explain more about this using an example. Okay, so R is newly introduced starting from C++11. So let's see what happens if we do not use the R. R stands for row string literal. So assume that string types of temp variable stores this string. And if we print this, let's see what happens. What was the name of this one? So if we print this temp variable, the output looks like this one, because it prints S here, and then tabs here because of the escape sequence. So here tabs goes here, and then it prints the /t here, and then this escape sequence means U line, so it goes to the next line and prints A. So this is the result of this string. But sometimes we want to print like this one, ignoring the escape sequences. So for that case, we use capital R like this. So we change code to this way, and let's compile again and run it. Okay, so if we change source code to this way and compile this, it gives a compiler error. The compiler errors, you need to have ability to fix compiler error. So I will fix compiler error with you. So the compiler error here says use of undeclared identifier R and expected semicolon at the end of the declarations. Okay, this arrow indicates that compiler cannot identify capital R. This is because this row string is introduced starting from C++11. So when you compile this program, you have to specify the versions of the C++ programming languages. So for example, G++. So like this, you can specify the language versions. So because our row string is introduced starting from C++11, so I specify C++11 here. So if I compile the program like this, there's no program error now. And if I execute it, as you can see here, it prints as we expected this. So in this way, compiler do not interpret it \t as t tab and \n as U lines. So this is very useful when you are dealing with a file, because file name, most of file name consists of the path. So for example, if you look at this, the file name includes the /a or \. So this is useful when you are dealing with a file path. Okay, so let's go back to the slide notes. I just explained that row string is useful with / in the file path. If there is no row string features, you always have to use double / for your file path, which is not convenient to doing it. So this is the code we have just looked at it.